Intermediate Algebra, Section 7.5, Terms with Differing Indices. If radical terms have different indices, we cannot multiply or divide the terms by simply multiplying or dividing radicands. However, we can often convert to exponential notation, use the rule of exponents, and then convert back to radical notation. In this first example, that's exactly what the problem is. We don't have the same indices, so we cannot multiply the radicands together under the common indices, since that isn't the case. So instead, we will put this in an equivalent exponential form, remembering that the indice on the radical becomes the denominator of our exponent. Likewise, with the second term, so we have 4 to the 1/4. This now gives us common bases multiplied together, where we will add our exponents. We need to get a common denominator for our exponents to simplify the addition. Common denominator between 3 and 4 is 12, so we'll multiply the first fraction top and bottom by 4, the second fraction top and bottom by 3, recognizing that 4 over 4 or 3 over 3 is equivalent to 1, maintaining our equivalency then. So in the first fraction, we end up with 4 to the 4/12 when we multiply. The second fraction is 3/12. We now have our common denominator. Multiplying our bases together, we'll add our exponents. 4/12 plus 3/12 gives us 7/12. There's nothing to be done with that exponential power as far as simplifying that rational expression. We're ready to put this back in radical form. The denominator of our exponent is the index of our radical, and so we will have the 12th root of 4 to the 7th power for our simplification. In the next one, very similar, we have a square root of 2x times the cube root of x, and because the indices aren't the same, we have to convert these into exponential form. So we have the radicand 2x to the 1/2 power times x to the 1/3 power. Simplifying using our exponential rules, we have a product raised to a power that will simplify, but in anticipation of eventually having common bases, let's get a common denominator on our exponents. The least common denominator between 2 and 3 is 6. Multiplying top and bottom by 3 in the first fraction will give us that denominator of 6. Multiplying top and bottom by 2 will give us the denominator of 6. So we have the product, 2x raised to the 3/6 power means 2 is raised to the 3/6 power. X is also raised to the 3/6 power times the second x that we have, which is raised to the 2/6 power. Simplifying further, we could reduce this, but we have to keep in mind the fact that we're going to put this back into a radical form. So having that common denominator will allow us to use one radical with the indice that's common in the denominators of these. So I'm going to leave the 2 to the 3/6 power alone. Common bases of our x multiplied together will add our powers. 3/6 plus 2/6 is 5/6. We're now ready to put this back into radical form. Our index is 6th. We're taking the 6th root of 2 to the 3rd power, which is 2 times 2 times 2, or 8, and x to the 5th power. Keeping in mind that that 6 in the denominator of each of these exponents is the index on our radical. In this next one, it doesn't matter if it's a multiplication or a quotient or division of radicals. We use the same procedure. We're going to convert it into exponential form because our indices are not the same. So in the numerator, we have m to the 2/3 power over m to the its square root, so it would be an equivalent of 1/2. Common bases, we subtract our exponents, so we have m to the 2/3 minus 1/2, and to subtract those rational exponents, we need to have a common denominator, which would be 6. So we'll multiply the first fraction top and bottom by 2, the second fraction top and bottom by 3, which is going to give us a 4, 6. So we have m to the 4, 6 minus 3, 6, which leaves us with m to the 1, 6. Nothing to simplify. We're ready to put it back in exponential form where the denominator of the exponent is our index on our root and m to the first power, or simply m, is our radicand. In this last example, we have essentially, if you can think of it in terms of polynomial, we have a monomial times a binomial. We'll use our distributive property, and while we're at it, I'm going to convert our radical to exponential form along the way. The fourth root of this radicand means that the radicand is raised to the 1/4 power times the first term, which is the radicand to the 1/3 power, the equivalent, minus, we go back to our term out in front, which is the radicand xy to the second raised to the 1/4 times the second term here, which is the radicand of x squared y to the third raised to the 1/5 power in place of the radical. Because we have a product raised to a power, we'll take our product, each factor to that power. So we have x to the 1/4, y to the second raised to the 1/4. Here we have a power raised to a power. Multiply our exponents, gives us 2/4, and I'm going to leave it as 2/4 because of the possibility of combining our exponents and needing a common denominator. Here we have a product raised to a power. That means x is raised to the 1/3 as well as y to the 1/3. This first term is just like we had here, so it's x to the 1/4 times y to the 2/4 when we raise that product to the power. And in our last expression here, x to the second raised to the 5th would be x to the 2/5 when we multiply exponents, and y to the third raised to the 5th would be y to the 3/5. We have multiplication, subtraction, multiplication. In our multiplication, we have common bases. We can use commutative property and get our like terms together. With common bases, we're adding exponents, and a common denominator between these rational expressions would be a 12. So we need to head for a denominator of 12, and I'm going to convert each one of those, multiplying the first one by 3, the second one by 3, the next exponent by 4, and the last exponent by 4. So that we end up with x to the 3/12. I'm going to bring this x next so that I have my common bases next to one another. It was to the 1/3. It is now to the 4/12. Y to the 2/4, multiplying top and bottom by 3 gives us y to the 6/12, and y to the 4/12 when we do a little commutative property and put our like terms together. Similar here, common denominator between 4 and 5 is a denominator of 20. So I'm going to multiply by values that give us a denominator of 20. So this first exponential power, I'm going to multiply top and bottom by 5. Likewise, this next one. Here we need a 4 to bring it up to a denominator of 20, as well as here as well. So we have x to the 5/20. Commutative property with the multiplication, I'm going to bring that next x in line, and that's at 8/20. Our y is to the 10/20, and our last y is to the 12/20. We're now ready to take our common bases and add our exponents. So common base here, we have x to the 3 plus 4/12 is 7/12. and y would be to the 6 plus 4, or 10/12, minus common bases, multiply together, add your exponents, 5 and 20 make 13/20, and y to the 22/20. In this first expression, to simplify, we're done. We can reduce these, but again, we have to be mindful of keeping that denominator the same so that we can put these underneath the same radical with the same index. So our index on this radical of this first product will be 12, and we will have x to the 7th and y to the 10th, minus. Our index is going to be 20, but if you notice here on the y, it's to the 22/20. We have an improper fraction. 22/20 is actually 1 and 2/20. That means we have 20 y's, and so we will bring a y out in front of the radical, leaving the remaining 2 as our power on our y. So we will have y times the indice, which is from the denominator of our exponents, x to the 13th power, y to the, and again, 22 divided by 20 is 1 with 2 left over, so it would be y to the 2nd power is our simplification.